Hello, everyone, and thank you for joining me. Once again, my name is Jesse Davidson, one of the product specialists with Milestone. And today we're going to be going over is the ultimate in environmental workflow simplicity direct mercury analysis. So before we actually get into the meat and potatoes of today's presentation, I'd like to touch on some of the pain points associated with the mercury determination in the environmental lab using traditional mercury analysis techniques. As I'm sure many of you are familiar with, the pain points of the environmental lab with respects to variable workloads with rush analysis requests, bottlenecks with traditional HG analysis, such as those with CVAA and intensive sample preparation from acid digestion, oxidant addition and reduction of samples prior to your analysis, as well as occupation of your valuable fume hood space during your digestion procedure. If those digestions are incomplete, then you could potentially have interferences at the 254 nanometer wavelength due to undigested organic content. And obviously health and safety concerns with acids and other reagents during the process of determination of mercury. So now that we've touched on some of the pain points within the laboratory, what is on today's agenda? Well, to start, how does direct mercury analysis by EPA 7473 improve your overall operation and workflow? We are also going to touch on and review some of the pain points that are associated with CVAA and EPA 7470 and EPA 7471, and then go over the distinct advantages of direct mercury analysis over CVAA and the advantages that Milestone's DMA80 EVO offers for the environmental application needs in the environmental laboratory. And then we will also have a hands-on review of the operation of the DMA80 EVO and how simple it is to operate and integrate into your current laboratory setting. So first thing that I'd like to spike out is the sample preparation workflow for traditional techniques such as CVAA. As we all know, it's first going to take place by having a sample submitted to you for analysis. And then the next steps for your first portion of 7470A and 7471B is to actually perform a daily system calibration and CCV or continuing calibration verification on the system. This will take you a duration of time to perform a full calibration before you can even get into sample analysis or sample preparation. Once you have completed your daily CCVs and daily system calibration, you would then go into your sample preparation, either adding 100 milliliters of your sample for aqueous samples, or roughly around 0.5 grams to 0.6 grams for your solid samples. You would then add in your DI water or in your acids and mix thoroughly to ensure that there's a homogeneous mixture of the acids in your sample. From there, you would add in your oxidants and then go directly over to a hot heating plate or heating mantle to heat up within the fume hood for either 2 hours for aqueous samples or 30 minutes for solid waste material. Once we have heated up all of our samples, we will then go into the initial reduction of our oxidants and finally go into the final reduction into elemental mercury for a total mercury analysis, which will then be purged into an AAS and you would read the analysis results. The total time elapsed for this process for 20 samples is roughly around 4 hours. So because of this, this is not what we would consider the most efficient method for determination of mercury within the environmental laboratory. What would that determination be for mercury for the most efficient method? Well, that would be for EPA method 7473 for mercury. And in this description, this is the direct analysis by thermal decomposition, amalgamation, and atomic absorption spectroscopy for mercury. What is this applicable to within the environmental laboratory? For one, you can do total mercury in solids, aqueous samples, and digested solutions. And those digested solutions are going to include mobility extracts such as TCLP and SPLP leachates. After digestion by EPA 3000 series methods, you could then directly put them onto the DMA or onto a direct mercury analysis system and get your analysis results via EPA 7473. While the system while the method is not currently regulated for drinking water or effluents, the system does have the ability to do full detection needs for both of these. So what is the best workflow for total sample preparation for the determination of mercury? Well, for the DMA-80 EVO using EPA 7473, that would start with your daily continuing calibration verifications. So unlike with CVAA, where you would traditionally have to perform a calibration at the very beginning of your day before any sample analysis or preparation could begin, all you have to perform is a daily continuing calibration verification. And if you are within the expected ranges of your system, the next step would then be to go and weigh your sample into a boat, either a quartz or nickel boat, depending upon if you're using an aqueous or solid sample. You would then import it with a touch of a button or either enter the weight manually into the software of the DMA, and then take that sample and place it directly onto our 40 position auto sampler tray and press play on the system. It is that simple. Once you press play, the analysis results will come back in roughly around 5.5 to 6 minutes per sample. And finally, once you've completed the analysis overall, you can then export all of your data off as either a CSV, PDF, or Excel file. The total time elapsed for beginning of the day for 20 samples is roughly around 2 hours, so considerable decrease from CVAA. And because of this, that would be considered the appropriate and most time efficient and effective method for the determination of mercury within the environmental laboratory. So one of the things that I'd like to spike out before we actually go any further in this demonstration is just how easy it is to perform a sample analysis with the DMA and no sample preparation steps involved. So the first thing that I'm going to do now is I'm going to switch over to my document camera and show you my terminal and how I would real-time program in a sample for my system. So what I have here is a CRM that is San Joaquin soil. And you can see that I have a sample here that I'm ready to add in. I'm going to rename that sample as San Joaquin soil, or 2709A, which is the NIST name for it. And then you can see that I have a weight on my scale here. I'm going to zero that out. And I'm going to add roughly around 0.1 grams of this standard directly to my boat. A little bit more dense than I thought it was. All right, that's a good weight there. And then with a simple click of a button, this golden scale icon, I can directly import the weight from my terminal from my scale to my terminal. From there, I'm going to take my sample and place it directly onto my auto position tray here, my 40 position tray, and press play. And in 5.5 minutes to 6 minutes, I will have the sample analysis results for this standard. One of the very nice things about this system is that it'll give you a real-time internal diagram of what is occurring temperature-wise. So what you'll see here is this is our method parameters in red, and it's sometimes a little bit hard to see, I apologize. But as it goes up, you can see that the temperature profile will follow this directly. And then we have the voltages for our detectors that are listed up here in green. Once it has completed its run, it will switch over to a spectrograph where it'll actually draw real-time the peaks for each one of my curves. You can see here that this is a 75 nanogram CCV that would be a part of your daily calibration verifications. But once my results have come back for this CRM, I will then have that drawn real-time where it'll integrate and directly give me my analysis results. So while it is doing the analysis, let's go over some of the other additional benefits of why the DMA over traditional methods of HG determination. So if we take a look at CVAA versus DMA costs, if one analyzes the ROI of direct mercury analysis over CVAA, you will see that there's roughly around a 90% cost savings per single analysis and over the lifetime of the instrument. So what you can see at the bottom here is that including the reagents and materials that are needed, as well as the operator or analysis time, that for roughly around 40 samples or a full auto position tray on our DMA, that it will cost for CVAA $99. When you're considering Milestone's DMA-80 EVO, this is only going to cost you right around $10. For around 5,000 samples, or what the typical consumable lifetime would be for our DMA-80 EVO, you can see that that data extrapolates out to roughly around $12,400 for 5,000 runs, or $1,270 per run for 5,000 runs for the DMA-80 EVO. So a clear return on investment for analysis costs for each one of your sampling, a clear benefit for the environmental laboratory. And in order to visualize that distinct advantage of the DMA over CVAA, what you can see on the right-hand side of my screen here is a graph that depicts the full workflow for a single sample, all the way from acid oxidation, digestion, cooling, and purging of the organics, and then final reduction and analysis for CVAA, to the DMA's drying, decomposition, combustion, and amalgamation to the analysis side in 5.5 to 6 minutes for your determination. Because of this, you can have increased throughput throughout the laboratory, and you can have more efficiency with turnaround or sample requests for your analysis. There is no interferences with the DMA in particular because we are using a thermal decomposition process and do not have to go through acid digestion as with CVAA. And due to this, we are then going to see no need for reprocessing of samples, which you may have had to do or traditionally would have had to do with CVAA due to undigested organics around the 254 nanometer wavelength. So why the DMA-80 EVO in particular, and just a couple of the things that we are going to touch on. For one, it is very simple. The system has no sample preparation, as you've already seen, and it is very easy to use. So prior to me becoming one of the product specialists at Milestone, I actually spent most of my time as a field chemist performing all of the installations of DMAs across the United States. I found that typically I would have people operational in around 30 minutes and proficient to use the instrument by themselves with confidence after less than an hour's worth of time. So a very easy, simple, easy system to integrate into your laboratory. As for productivity, it has very fast results, as you're about to see. I'm going to have my sample finished up in a moment, and it has complete unattended operation. So you can load up 40 samples onto the auto position tray and then run with your day and do anything else that you need within the laboratory. As for convenience, we have the ability to analyze all matrices, and there is no oxidants, acids, or reducing agents that are utilized during the process of sample preparation. As for reliability, we have a high level of accuracy and precision, which I'll be going over a little bit more in depth in a moment. And we also have a very flexible sensitivity range based off of 3 different instrument configurations. And once again, no interferences due to the fact that we are using a thermal decomposition process and no acid digestion. So we are just about done with our first run here. And so what I am going to do is I'm going to switch back over to my document camera and show you how the analysis results will come out on the system, as well as what the system will show you while it is processing the peaks. So my document camera is pulling up now. You will see that I am at the end of my profile run here. And as soon as I hit that little PD time at the bottom there, it's going to switch over and it is going to show me the real-time drawing of my peaks for my system. So you'll see that is my first peak there, then a second peak, and it'll be followed by a third peak after this one. Once this has completed its full analysis and made sure that there was no mercury concentration left within the instrument and all interferences have been passed through, it'll take me back to my results screen right here, where I will see a real-time output of what my concentration is in either milligrams, kilograms, micrograms, kilograms, or nanograms, kilograms, so PPT, PPB, or ppm. So with my sample just now having finished, it's going to place the boat back onto my 40 position auto sampler tray. And then it is going to spit out the results directly into this column here. You'll see that on the system, there was an automatic BV or a cleaning on the system that happened because it was above a set standard value. You can see here that for my concentration, I had a concentration of 1.15, and that is going to be right within the expected range for the CRM 2709A or San Joaquin soil. All righty. So, what just occurred and what are the principles of operation for the DMA in particular? What I have here is a little snapshot video of the internal mechanisms or principle of operation that the DMA follows. So the first step will be to pick up a sample boat, place it into the drying and decomposition furnace, and heat it up to 200 to drive off any light volatiles and moisture, and then 650 to drive off any of our mercury. From there, it'll pass through our catalyst furnace where it'll be reduced down into elemental mercury, and it'll then collect on a gold amalgamator for around 30 seconds where our carrier gas pushes through any matrices interferences. From there, it'll heat up to 850 degrees Celsius, revolatilizing off all of our mercury on our sample or on our gold amalgamator, and then passing it through to our detector interference-free. Due to this process, it is a much more efficient and fully automated version of what your CVAA could do. All right, so now to get in a couple of the instrument operation features, what you can see here on the right-hand side, that is our standard method. And that method will be your single decomposition method for most samples. Once again, it is as easy as weighing your sample, loading the sample boat directly onto the auto position tray, and pressing start. From there, the system takes care of everything else with this simple little method where we heat up to 200 degrees Celsius to drive off those light volatiles and moisture, and then to 650 degrees Celsius to drive off any of our mercury and ash our sample. From there, we have a purge, which is going to ensure that we have no matrices interferences before the detection of mercury. And then we have our amalgamation, which is going to ensure that we fully volatilize off all of the trapped mercury on our amalgamator. We then finally will go into our signal record and get the analysis result all within 5.5 to 6 minutes. Once again, there is no sample preparation that is involved within these steps, and we are able to use the use of industrial grade oxygen or air as a carrier gas. My system is currently on an oxygen cylinder. However, we do have the ability to use a compressed air cylinder, primarily because we are not using that as a combustion purpose, but we are using it as a carrier gas to transport all of our mercury. Once again, there is also very minimal maintenance that is needed for the instrument. So with our system, there is no daily upkeep that you have to provide for it. The only thing that you have to do is change out the main consumables, which will be your catalyst and amalgamator, every 6 months to a year. So relatively low upkeep for the instrument overall, and a very efficient process for the determination of mercury. So with our DMA-80 EVO and direct mercury analysis, we can analyze all matrices under one calibration curve with no matrices interferences. So this gives us the ability within the environmental lab to analyze aqueous, solids, and soils, as well as air sorbents. One calibration will fit into each cell, and the system will fully calibrate in roughly around 2.5 hours, and has a very long calibration lifetime, as I've mentioned. So with our system, we like to say that the calibration lifetime will typically last you anywhere from 6 months to a year. And as such, we'll have a very long lifetime within the laboratory as long as you perform good laboratory practices. All of our mercury is also retained in an HG trap, which you can see is off to the side of my instrument here. And this actually allows me to have no fume hood requirements for the entire sample preparation process and analysis of mercury, because all of my mercury will be directly retained inside of this mercury trap, which then can be disposed of in the proper manners. So now that we have discussed the benefits of the DMA-80 EVO and the long lifetime of calibrations and consumables, what does the most efficient and successful curve look like for the environmental lab? What you can see here is what a traditional calibration would look like for the environmental lab, broken into 3 different cells based off of the configuration of the instrument. And what you can see here is that for our cell 0, this is going to be between 0 and 5 nanograms. And then our cell 1, which is going to be our medium range detection, is going to be from 0 to 25 nanograms. And our cell 2, which is going to be our higher level of detection, is going to be roughly around 25 to 600 nanograms, but does have the capabilities of going up to 1500 nanograms. With each one of these cells, the way that we break it out is because mercury flows sequentially through the system and through each one of the cells, starting with the cell having the highest sensitivity or our highest path length, which would be cell 0. From there, it would go into our mid-length pathway, which would be our cell 1, to our lowest sensitivity or lowest path length cell, which will be our cell 2. The system will automatically select the appropriate cell calibration based upon the absorbance value of the sample. And we will use roughly around 6 points per cell for a quadratic regression and a square approximation method for these calibrations. We do have an industry-leading calibration lifetime once again. So once you create this calibration, which will take you between 2 to 2.5 hours, this calibration will then last you for another 6 months to a year before you have to perform a new calibration. Before you start your day, you will perform a calibration verification on the system utilizing a secondary source calibration standard. And what will that actually look like? Well, this is what I have actually pulled up on my screen on my terminal before, as well as what you can see in front of you now. So to start off your day before you actually get into your sample analysis, you would start by performing your CCV with doing a system blank, a low-level CCV check, and a high-level CCV check. Once those come back within expected ranges, you would then perform a batch QC, starting with a method blank, an LCS utilizing an SRM, which would be our recommendation, then followed by a sample dupe, and a sample spike. Once you have completed the sample spikes and sample dupe, you will then perform another mid-level CCV, and finally a continuing calibration blank. This would those last 2 points would then be repeated for every 10 samples at the end of the run. This process in totality takes roughly around 1 hour from start to finish, and this is going to be instead of the 2 to 2.5 hours that you would have to perform with CVAA and performing and creating calibrations at the beginning of each day. All right, so what you can see on this slide are just a couple of the different dedicated configurations for sensitivity needs within the DMA line. So what you'll see on the left-hand side there, and actually is the instrument that is directly behind me here, is our DMA80 EVO tri-cell system. And this is the one that is the typical configuration for most environmental labs because it gives you the best range as well as the lowest levels of detection. So with our DMA80 EVO, you have the ability to actually go down to roughly around 0.05 nanograms and then up to 1,500 nanograms if you have samples that'll be around there. For the detection limits, we have the ability to go down to 0.05 once again, and it has excellent stability at that signal and at that detection level. What you can see at the bottom of my screen here is that this is a sample between a system at 30 ppb from our 6th generation and between our 7th generation system. And this is the addition of a double beam spectrophotometer, which allows us to have that excellent stability of our signal, and it enhances the signal to noise ratio during a detection. So on the left-hand side, that is going to be a 30 ppb sample for our 6th generation tri-cell. And on the right, that is going to be the 7th generation tri-cell that includes the double beam spectrophotometer. And you can see that it cleans up the baseline and allows for much cleaner symmetry of our peaks, which is going to allow for better reproducibility at the low level of detection. Now, based on typical sample mass of around 0.2 grams, the limit of quantification on our system for both aqueous and solid samples is going to be around 0.1 ppb. We also do have 2 other dedicated configurations, which will be our DMA80 EVO dual cell system. And this has the ability to go to 0.5 nanograms up to the same top end as 1,500 nanograms as our tri-cell system. And then our DMA80 EVO wide range, which has the ability to go from 2 nanograms up to 30,000 nanograms. The benefit of the wide range is that if you have samples that are going to be very high or higher than expected from your traditional measurements, it is utilized within the environmental laboratory as a phase or a trial testing to ensure that you're not overloading your low detection system. All right, so now we're going to go over a couple of the other additional features that the DMA80 EVO provides. And one of my favorites is, and it's actually something that you can see currently, is that we have a backlit logo on the system. These are going to give you a real-time display of the system status. So what you'll see on my screen here is that I have a white, yellow, red, and a green color. That white means that the system is ready to operate and run an analysis. The yellow is when you first turn the instrument on at the beginning of your day. And there's the initialization of the system and heating of the system, which takes roughly around 5 to 10 minutes at very most. We then have that red color on the top right, which is going to indicate that I am currently performing an analysis on the system, and then a green light that is letting me know that I have completed the analysis for my system, and I can either start a new batch or add additional samples. One of the nice things about this for me particularly is that my office is directly behind the camera, and because of that, I don't have to stand in front of the DMA all day long. I can load up my samples, and as soon as I've noticed that the samples are completed or the color has changed on my system to green, I could then come back to the front of it and not have to worry about it throughout my shift. We also have the ability on our newest 7th generation system to go up to 1,000 degrees Celsius for our catalyst furnace. What are the benefits of being able to go up to 1,000 degrees Celsius? Well, as you all know, mercury is an extremely sticky compound, and as such, we want to ensure that between runs or after high load mercury samples, that we are completely cleaning out the catalyst furnace and the drying and decomposition furnace. By being able to go up to 1,000 degrees Celsius, we will ensure that we can fully volatilize off all of the mercury that is directly built on or baked into any of the components of the system, and then ensure that the next sample will have no cross-contamination from the previous one. And then one of the things that I showed you before is that we have full balance connectivity. So what you can see here is that I have a scale that is directly integrated into the terminal of my system. And one of the great things about this, and the great story that I always tell, is that we had a customer that had a transcription error for the weight of one of their samples that went all the way out to a customer. Because of that, their auditing body actually dinged them, and their corrective action was to get 3 scales for the 3 DMAs that they had within their laboratory and directly integrate the weight process to the terminal. Because of that, and because of the corrective action that they performed, their auditing body signed off on it, and they were then back into their normal analysis of the system without any worry for transcription errors that can go out to the customer. So a nice handy feature overall that you can benefit from with our scales. Just to go over a couple of the built-in features for the DMA80 EVO, we do have an auto blank feature, which you can see actually occurred during my analysis of that SRM material, where it'll ensure that there is we avoid any carryover between sampling, and it is fully automatic on the system. The system also has full 21 CFR compliance, where you can have a full history trail and access levels and individualized accesses for the system. And we have full LIMS connectivity ability for it. We have the ability to do facility data management, where you can export all of your data and report it as either a CSV, XLS, or PDF file. And you can perform data post-processing, where you can recall and re-report all of your data. And then finally, we have our Milestone Connect, which I will briefly touch on at the end of this presentation. So with our auto blank feature, I'm just going to port back over to my terminal screen here again, and I will show you how it actually affects your run. So with my sample, this can be completely tuned into what your expected concentration ranges are. And what you will see here on my terminal is that with my 2709A, that it was around 1 ppm or 1.1 ppm of concentration, and that it then kicked on this automatic BV of my system, or the automatic blank of my system. You'll see that there was a concentration of mercury by this height here on my system, and if I did not complete that auto blank, then potentially could have had crossover into the next sampling. As such, this is a great feature within the environmental laboratory, especially with the high pace speed of the lab itself. And it can ensure that you have you can eliminate entirely the need for sample reanalysis. And you can once again set this to a user-defined blank level so that you can blank down to a completely clean system prior to the analysis of any of your other samples, which also allows for complete and unattended operation of the DMA. So one of the other things that I always like to mention is that we have and provide you free of charge our Milestone Connect. And this is essentially your access to all of Milestone and the DMA80 resources that we have built over the past 30 years at Milestone. We have a complete remote monitoring of the system ability, so that if you have your analyst working on the system or your chemist working on the system, and you would like to see what the results are, you can actually monitor them directly from any tablet, PC, or phone that is connected to the internet from anywhere within the world. This does not allow you to start runs, but it does allow you to see the system status. We also have full application notes and application reports directly on this platform, and full scientific paper library of anything that has ever been done with the DMA. Also, one of the nice convenient features is, let's say you have a new person that is starting within the laboratory, and instead of delegating your valuable time to training them on this instrumentation, we have full tutorial videos and quick start guides to get them operational within 30 to 40 minutes. So a very fast way for you to then transfer off the baton to the next user of the DMA. And we have all of our user manuals directly on here as well. All right. So why the DMA-80 EVO, and why is it the most simple way to actually perform determination of mercury? For one, it is a direct reference method in the instrument that was utilized for the reference method for EPA 7473. And with the system in particular, you have a high level of performance with reliable results, great sensitivity, and ease of operation, as you saw me perform, with as simple as just taking your sample, weighing it out into one of our boats, importing the weight onto the terminal of the system, placing it onto the 40 position auto sampler tray, and pressing play. It is a very cost-effective procedure because there is no sample preparation cost, as with traditional methods like CVAA, and there is no acid waste that is generated or the need for acid waste disposal. And overall, it is less labor because the only contributions that you or your analysis has to perform is by taking the sample, placing it onto the auto position tray, and then going about your business for the next 40 samples or the next 20 samples on your position tray. It is also a green technology because there is no acids, oxidants, or reductants that are utilized. And there are no fume hood requirements due to the ability to utilize a mercury trap that is off to the side of the instrument. Overall, this allows for reduced risk while operating with the DMA because there are no worries or concerns for acids or fume hood requirements. And then obviously you have customer support when utilizing the DMA from the application leader in knowledge for direct mercury analysis. Thank you very much.